Hi, I'm Veli from Greenwood Solutions. This week's presentation is on the grid application process. The reason why grid apps are required is that you're asking permission to put a commercial solar system on to an existing infrastructure owned by the distributor. This is not an agreement with the retailer, with the customer's retailer. It is an agreement with the actual distributor. So there's certain things that you need to get dead right. Customer site specific information, contact to check details, application form, CAD drawings, SLD, schematic and site layout, voltage rise calculations, functional statement, protection study, commissioning plan, product data sheets and generator D. Basically, you have to ensure you have all the information necessary and have prepared the following documents that will need to be uploaded. The Customer Authority to Act form, the SLD sketch of the site in question, the panel data sheets, the inverter data sheets, and the photo of the main switchboard and photo of the meter. Aerial view, site layout, panel, inverter, PVDB, MSB, and point of supply location. Grid apps are really important. Those distributors are really hard on any mistakes. Make sure you don't make any mistakes at all in regards to the documentation. Name, rank, serial number. Attention to detail is a must. One of the key things to consider when doing a grid application is proofing the information obtained from the customer and the installer. Whether it be ensuring customer information is correct, ABN, company name, etc. System design from point of attachment all the way back to the panels is correct. Voltage rise is within the allowable 2%, and so on. All distributors require submission either online or via email detailing the install specifics. As a necessity, all grid applications include CAD drawings. Voltage rise is of paramount importance because the system must adhere to no more than 2% voltage rise from the point of attachment, or more specifically, the transformer pillar to the inverters. Functional statement. It is best practice to describe to the distributor what is being installed and its functionality. It should contain a description of the generator. For example, the proposed embedded generator at X address is a 513 kilowatt Grid Connect solar array comprising of 1,595 panels at 325 watts each, 19 by 27 kilowatt inverters with export limiting to be confirmed. The system has been designed and subsequently sized to offset installation maximum demand and provide general power savings along with potential network load shaving. Now, we've been doing grid applications for many years for a lot of businesses, so we've got that down pat. We've got 3 engineers who do it, so they seem to know what they're doing. But even if you don't come to us and ask for that service, or you go elsewhere, just be aware to factor in the cost to outsource that particular service and factor that into your costing for your next project. It should show the inverter initialization process, remote monitoring and functionality, emergency contact information, description of functionality including but not limited to monitoring interval, export limiting, secondary protection functionality settings, inverter power factor. It is best practice to have an in-depth explanation of the protection devices throughout the installation, from the MCCB to the MCBs to the GridSafe, the secondary protection board and its parameters. Some distributors have specific stipulations in regards to where things can be connected to. For example, AusNet requires that the secondary protection board that we've talked about in another presentation is connected directly to the main switchboard, whereas a lot of the other distributors don't mind if you connect to a distribution board. So it's really important to know those things. Most distributors require a commissioning plan. This can include the CEC commissioning plan, but also how the GridSafe or secondary protection board is programmed and how it will be injection tested and export functionality if necessary. This is relatively self-explanatory, and you must include panel information, inverter information, and the monitoring data sheets along with your submission. The generator deed is supplied by the distributor for the customer to sign. Once both customer and the distributor sign the generator deed and it is executed, means the application is finalised. This is typically supplied when connecting to the grid for a feed-in tariff. Also remember, some states have additional costs. For instance, in Queensland, you need the services of an RPEQ, which is a registered practicing electrical engineer from Queensland, whereas in Victoria, you don't need that. Also, just beware to factor in other additional costs outside the grid application process, like secondary injection testing or power quality testing, which is a requirement for some of the distributors in Victoria. Conclusion: ensure you have all the information necessary and have prepared the necessary documents. Information from customer needs to be proved to avoid any delays. Voltage rise is of a paramount importance because the system must adhere to no more than 2%. Some states have additional requirements which incur additional costs. We really hope you enjoyed this week's presentation on the grid application process. If you have any inquiries about an upcoming project or any questions in general about grid applications or some answers, please feel free to drop us a line and hit that subscription button if you see fit. Thank you. Bye.